Okay, this is number 3 on the handout for section 3.3, and we're talking about Penny training for a race. She's running full speed and then she walks back the same distance. So anytime we talk about distance, running, walking, anything like that, you know we're going to use our rate times time equals distance formula. And if you looked in the book, to set these types of problems up, they make a chart. And it does really help. If you don't want to make a chart, you don't have to, but I'm going to show you. And it really helps me a lot. It breaks it down, it makes it easier. So just watch it, watch the video, see how you feel about it. If it makes sense to you, go ahead and make a chart. If you want to do a different way, you got to do what's best for you. So we're talking about running and walking. She's running and walking. And I'm going to make a column for the rate. I'm going to make a column for the time. And then I'm going to make a column for the distance, because rate times time equals distance. And we remember rate is how fast she's running and walking. Time, how much time does she spend running and walking? And then that's the D's for the distance. So let's see, if you read through the problem, do we see how fast she is running? Do you see her speed? And I see it right here. 9 miles an hour for walking. I'm sorry, for running. Holy moly. Okay. So I'm going to put a 9 there. Do we see how fast she's walking? I see 3 right here. Okay. So she's walking 3 miles an hour. Whoops. Okay. How much time is she spend training? Let's see. Let me use a different color. I've got 5 hours training. And what are we looking for? Here's what we're looking for. How long does she spend walking back? So X is going to be the time spent walking back. That's what they're asking us. That's what we need to find. So I put my X in the time column because that's what we're looking for. Okay, if she's walking this X time, well, we know she spent a total of 5 hours between walking and running. That 5 has to come into play somewhere with the time. So if she walked 2 hours, could we figure out how long she ran if she spent a total of 5? So we would just take 5 minus 2 and get 3. So that's what we can do for the running. We know she spent a total of 5. Hours training, and we know she walked X hours. So we can take that X away from the 5. So 5 minus X is our time for how long she runs. So we know rate times time equals distance. So we're going to take rate times time. Going to take 9 times 5 minus X. And 3 times X is just 3X. Good so far? And we know that she's walking and running the same distance. So if we know that, we can set these two distances equal to each other. I'm sorry I keep bumping this. So we can set these two distances equal to each other because it's the same amount of distance. And then we're just going to solve this like we did in chapter 2. We're going to distribute here first, right? So I get 45 minus 9 times x equals 3x. Okay, now I have my numbers all on one side, but I don't have my x's on one side. So how do I get rid of this? Or what is the opposite of subtracting 9x? I'm going to add 9x. Okay, so these go. And 45 equals 3x and 9x, which is 12x. And what's my last step? I'm going to divide both sides by 12. So when I do that, if you want to punch that in, you can. Take 45 and divide it by 12. Okay, I get 3.75, or 3 3/4 hours, or 3 hours and 45 minutes. You can just leave it 3.75 if that's the easiest for you. So she took 3.75 hours to walk back. So that means how long did she spend running? Could we find that? We know it was a total of 5, right? 5 hours. So 5 minus, let me put how long did she run? And that'll give me 1.25 hours, or an hour and 15 minutes, or you can just say 1.25. But we're looking for the walks. How long did she take walking? So that's the answer, 3.75. Okay. If you need to pause and go back, if you want to go back over the chart, or if you have any questions on that, let me know. But I'm going to go to number 4. And number 4, we don't need a chart. We're taking an average. And I did an average at the beginning of the first video. So they're giving us 1, 2, 3, 4, 5, 6 times. And they want to know how many minutes will he have to spend on his 7th ride to get to his goal of 53 minutes. So we want an average of 53 minutes for these bike rides. So remember what we do first. If you need to look back, we're going to add all these numbers up. Right, so we're going to say 46 plus 58 plus 56 plus 45 plus 47 plus 60. There's our 6 times he rode his bike. But then we're going to add in an X. We don't know how much that 7th time is, okay? And there's actually 7 times here. So we're going to divide by 7, and we want this to come out to an average of 53. So here is our setup. We're adding all the minutes together, the 6 different minutes or times together, and there's really 7 rides. So we're going to add on an extra one for the 7th ride, but we don't know how much that is. We're going to divide by 7 because there's 7 numbers, and we want our average to equal out to 53. How much does he need? What time does he need to make on that 7th ride to get to an average of 53? So when I add all these up together, add all these 6 numbers up together, I get 312. So I just added all the 6 scores together, plus x, still divided by 7 equals 53. Okay, I'm going to put a 1 underneath here. 53 over 1 is still 53. And this looks to me like it's a proportion. So remember, whenever I have a proportion, I can cross multiply. Does that ring a bell? So I'm going to take 312 plus x times 1. Well, that's just 312 plus x. In case I run out of paper here. And then 53 times 7, if I punch that in the calculator, that gives me 371. Okay, good so far. So, what can I do to both sides to get this x alone? Can I get rid of this 312? And how would I do it? So I'm going to subtract 312 from both sides. See what x is. What do I have to get, or what does he have to get on that 7th ride? So I'm going to borrow, make this an 11, borrow from here, that becomes a 6. And I'm getting 59 minutes. So my answer is 59 minutes. He's got to get that on the 7th ride to get an average of 53. So those are problems 3 and 4. I've got 2 more for you, and those will be in the next video.